The formula for ANOVA is F equals MSE divided by MST, where F equals ANOVA coefficient, MST equals mean sum of squares due to treatment, MS equals mean sum of squares due to error. One-way ANOVA. Let us look into one-way ANOVA formula. F equals statistic or F ratio. F equals MSB divided by MSW. In this formula, F equals coefficient of ANOVA, MSB equals mean sum of squares between the groups, MSW equals mean sum of squares within groups. One-way ANOVA analysis of variance is commonly called a one-factor test in relation to the dependent subject and independent variable. A statistician utilizes it while comparing the means of group independent or of each other using the analysis of variance coefficient formula. Two-way ANOVA. The prerequisite for conducting a two-way ANOVA test is the presence of two independent variables. One can perform it in two ways. Two-way ANOVA with replication or repeated measures analysis of variance is done when the two independent groups, dependent variables, do different tasks. Two-way ANOVA sans replication is done when one has a single group that they have to double test like one test. Moreover, one must meet the following condition for its application. First is the population should be near normal distribution. Second is the sample should be independent. Third is the variances of the population have to be equal. And lastly is there should be an equal size sample in the group. There are four assumptions that must met before using two-way ANOVA. First is the normality. Observation from the sample population are normally distributed. Second is the sample size. The number of observation must be the same for each group. Third is the equal variances. The variances for each group are equal. And lastly is the independence, which is the observation in each group are independent. How to perform a two-way ANOVA? First, visualize the data. It is always convenient to display the data so it is easier to work with. If the data is not organized according to the factor, the result of the step will be difficult to follow. Second, set up the two-way ANOVA table. A two-way ANOVA table displays all the results of the two-way ANOVA analysis. Third, calculate the sum of squares for both factors. The first step toward calculating the sum of squares, the first column in the two-way ANOVA table is to find the means for each factor and the total mean. To do this, add up the value of the response variable for one factor and divided by the number of observations within that factor. Repeat this process for one other factor to find the total mean, and add the response variable values and divide it by the total number of observation. Fourth is calculate the sum of squares within to find the sum of squares for the within rows. First, calculate the sum of squares for all the combination of factors. Fifth is to calculate the total sum of squares. To find the total sum of squares, apply the sum of squares formula to the response variable for all observation and use the total mean as calculated in step 1. Number 6 is calculate the sum of squares for the interaction effect. After calculating the other sum of squares, find the same for the interaction effect by using this formula. 7 is calculate the degrees of freedom. The next column in the two-way ANOVA table is the degree of freedom, which is the DF. The degree of freedom is the number of values in the data after completing the calculation. Lastly is the number 8, which is calculate the mean square.